4.2. We're trying to accomplish exactly the same goal. We're trying to find the solution to a system. But we're going to throw our graph paper away for this lesson. We will not graph anything, and yet we're going to find an algebraic technique for solving a system. What I'm going to need to solve a system, and I have it written right here, and you may want to write this down as well. It says, and I'll read it slowly, to use the technique called substitution. To use the technique called substitution, one of the equations in the system should be in the form either x equals or y equals. So let me read all of that again. To use the technique called substitution, one of the equations in the system should be in the form either x equals or y equals. Whoops. Either x equals or y equals. Should be in the form x equals or y equals. What do you think of when you hear the word substitution? You're going to put something in the place of something else. You're going to replace something. That's what we're going to do when we're using substitution. Look at this system. Even though right now you may not know anything about the technique of substitution, I have told you the form. Is one of these two equations in the correct form? Yes, the top one. She sees that the top equation says y equals, and that's what I need. What I'm going to do, what I encourage you to do, is circle this, meant to have red, circle this. That is, it says 2x plus 1. That is a name for y. So I'm going to take it and plug it in the place of y. I'm going to substitute it. Now, I'm going to copy this over. I have y is equal to 2x plus 1, and I have 4y minus 6x is equal to 10. I decided that my format was good. Because it says this is a value for y. I'm putting it in the place of y. When I do that, it's going to say 4 times, not y anymore, but 2x plus 1 minus 6x is equal to 10. Okay, is everybody okay with what I've done? I've substituted an expression in the place of y. What did it give me? An equation in just x. So I can solve it. I can use the distributive property. That gives me 8x plus 4 minus 6x is equal to 10. I can combine like terms. I'm going to have 2x plus 4 is equal to 10. Subtract 4 from both sides. 2x is equal to 6. And x is 3. Now, I am a little bit used to thinking my problem is done when I get something like x equals 3. But I'm solving a system. What kind of solutions do systems have? They need two. They need an XY ordered pair. I only have X. So I'm going to write down, now find Y. Now find Y. This is similar to a T-chart, although I'm not going to draw any charts. If I know an X value, because X is 3, can I just plug it in for X and crank out the Y? And it doesn't matter whether you use this equation at the top or the second equation, but I'm going to tell you that the easier one is the circled one. The easier one is always the circled one. So when it says to find Y, I'm going to write down Y equals 2x plus 1. I'm going to plug in Y is equal to 2 times...
You're going to do the same equation that you plugged in?
Yes, yes, the circled one in my notes.
Okay, that's what you said.
So Y is equal to 7. But, you know, I really want to show you, you don't need to do this twice. But you could, if you wanted to, I could write down 4y minus 6x is equal to 10. And I could plug it in here. That's 4y minus 6 times 3 is equal to 10. I hope you're about to see that this is a lot more work. So 4y minus 18 is equal to 10. Add 18 to both sides. 4y is 28. Divide by 4. Y is still 7.
So it's our ordered pair 3, 7?
Yes. Okay, so let me pause for just a second. I recommend that after you find your first variable, that you go back up to the circled equation and use it. It will be easier. You don't have to, but you should probably. The ordered pair is the x, comma, the y that you found. So your answer is 3, 7. I found the point of intersection, and I never graphed a line. But I promise if you did graph these two lines, that they would cross at the point 3, 7. Substitution is an algebraic method to accomplish the same thing. So let's practice it a few times. Question number 2, I'm going to rewrite the system. I have 4x minus 7y is equal to 6, and I have y is equal to x minus 3. Is this system physically ready for me to work substitution?
No. Oh, well, yes.
Okay. You have to have either x equals or y equals staring at you. And I see y equals. So I'm going to circle this expression for y. And where am I going to send it? To the other equation in the place of y. I'm going to start it and say 4x minus 7 times, and I use parentheses. It's not going to be 7 times y, it's going to be 7 times x minus 3. And that equals 6. So I physically lift up x minus 3 and put it in the place of y. And now I have an equation in terms of x again. Solve this. Distributive property. I have 4x minus 7x plus 21 is equal to 6. 4x minus 7x is negative 3x plus 21 is 6. Subtract 21, 3x is negative 15. Final step, divide by 3. Did y'all get x is negative 5?
Yes. How'd you get negative 3?
Okay. I dropped it. I will put it back, and thank goodness somebody was watching me. Okay, let me recap, including my mistake. When I went from this step to the next step, I neglected to carry down the negative sign with my 3. Okay, but y'all found it, so I've done that now. Now the coefficient of x is -3. Divide both sides by -3, and I get +5. Okay, so y'all caught my mistake. All right.
Wait a minute, I'm lost.
Okay, at what point?
Okay, up here, okay, you do your distributive,
Yes,
so that's
-7.
-7x,
Mm-hmm.
and that's +21.
Yes,
Okay, then you got your 2x's over here, so you subtract, so that's 3x.
and it's -3x because the bigger number was the -7.
Plus 21,
Mm-hmm.
then you divide by 3.
No, not yet. You subtract 21 from both sides. And that gives you -3x is equal to -15. And then divide. What do I have to do next?
Plug it into y.
Right, so now find y. I'm going to go back up, and I can choose either equation, but my choice is always the circled one because it's going to be easier. Y is equal to x minus 3. Take your value for x. And I have y is equal to 5 minus 3, which is 2. Y is 2. Which means, what is the ordered pair?
2.
It is 5, 2. Let me ask you a question. Of the 3 scenarios that can occur in graphing, they looked like this. One of them was intersecting lines, one of them was parallel lines, and one of them was the same line. Which of the scenarios is true for this problem?
The first one.
The first one. And how do I know? Because I got an ordered pair. I got a point. Before we finish, you'll see what happens that indicates you're in one of these two. But when you get an x and a y, you're dealing with this scenario. All right, let's look at the next one. Unfortunately, the world is not always perfect. And so sometimes you end up with systems that are not ready to do by substitution. Let me write this one out larger. I have x plus 10y is equal to 17, and 3x plus 5y is equal to 1. Do you remember what I said had to be true in order to use substitution?
To be an x.
You have to have either x equals or y equals, and I don't have it. So I have to change one of these, and I have the algebra skills, you have the algebra skills to do this. But let's make the best choice we can make. In the first equation, if somebody said you can either make it in the form x equals or you can make it in the form y equals, which one would be easier?
X equals.
Okay, I got both answers. Why do you think x equals would be easiest?
You can divide by its reciprocal.
When it comes to solving for x, do you agree that you would have to subtract 10y from both sides? Then would you have to divide by anything? No. The coefficient of x is a 1. That makes it the easiest one to solve for. If I solve for this y, I'm going to have to subtract x, then I'm going to have to divide by 10. I don't want to do that. If I solve for this x, I'll have to divide by 3 at the end. If I solve for this y, I'll have to divide by 5 at the end. Try, if you can, to solve for a letter whose coefficient is 1. So I'm going to highlight around that one because that's what I want to solve for. All right, I am going to draw a double arrow saying I'm off to do some work. I'm going to take x plus 10y equals 17, and I am going to solve for that x. I'm going to subtract 10y, and that gives me x is equal to negative 10y plus 17. Is that better? All I did was subtract 10y from both sides. I changed this first equation into a form of x equals. So what I'm going to write now is that I have a new system. I have x is equal to negative 10y plus 17, and I have 3x plus 5y is 1. Okay, so the first equation I changed, so I wrote it down. The second equation, all I did was copy it. Am I ready for substitution now? Yes. So I'm going to grab this expression, which is the same as x, and I'm going to plug it in the place of x. I have 3 parentheses, not x, but negative 10y plus 17 plus 5y is equal to 1. Does everybody see where I got that? That's the value for x. I put it in the place of x. Let's solve that equation. Distributive property, that's negative 30y plus, I think 3 times 17 is 51, plus 5y is 1. What is negative 30y and positive 5y? Negative 25y plus 51 is 1. Next step, subtract 51. Negative 25y is equal to negative 50, because I had negative 51 and 1. Divide by negative 25, and y is positive 2. Am I done with the problem? Nope, not yet. Now, find x. Well, look back. What am I going to use? I'm going to put x equals negative 10 plus 17. X equals negative 10, y, no, is that right? Plus 17. All right. Put in the 2. And I've got x is equal to negative 10 times 2 plus 17. X is equal to negative 20 plus 17. So what is x? Negative 3? My ordered pair? Negative 3, 2. Even though I got the y before I got the x, when I write it as an ordered pair, make sure that you write it in the order xy. I think we're going to skip number 4 because it doesn't provide anything new for us, and we're going to go to number 5. If you look at the printed notes that'll be posted online, I will have done all of them, but in this video I'm going to skip number 4. All right, number 5. I have 5x plus 10y is 35, and 6x plus 12y is 48. Is this system ready for substitution? No. And if I look at all of the terms, I don't even have one that has a coefficient of an implied 1. I don't have a plain old x or plain old y. So I think, well, which one would still be the easiest to solve for? This one would be fine. Because if I solve for x, what would I have to do? I'd have to subtract 12y, that would send it over there. I'd have to divide by 6. Would 6 go into the 12 evenly? Would 6 go into the 48 evenly? So that would work out. Or, same with the top one, if I solve for this x, and I move the 10y over here and divided by 5, would it go into the 10 and the 25? Okay, do you have a preference? if y'all don't mind, I'm going to do this one because it's what I did in the printed notes. And that way it'll be the same. All right, if I take 5x plus 10y is equal to 35. And I'm solving it for x. Let me highlight that so you know that that's what I'm choosing. I'm going to subtract 10y. That leaves me with 5x is equal to negative 10y plus 35. And my final step, divide by 5. 5 by 5, divide by 5. And x is equal to, what will the coefficient of y be? Negative 2y plus 7. Now, some people don't like to do this extra writing, but in the notes, I always then stop and say, okay, I have a new system now because I've made some modifications. The top equation has become x is equal to negative 2y plus 7, and the second equation has stayed 6x plus 12y is 48. I am going to take this value for x, and I'm going to substitute it in the second equation in the place of x. That gives me 6 parentheses negative 2y plus 7 plus 12y is equal to 48. Use distributive property. That's negative 12y plus 42 plus 12y is 48. Let me pause. Is everybody okay with the substitution and the first step towards simplifying? What happens when you combine like terms? Do the negative 12y and the positive 12y cancel? Okay, and so all I have left is 42 is equal to 48. Now, do you remember this happening to us back in chapter 3? No, it was chapter 2, I'm sorry. Back in chapter 2, we solved equations, and once in a while, the variables dropped out. We checked the statement that was left over. Now, 42 equals 48. No, this is a false statement. Do you remember that when a statement was false, you had no solution? So this is a no solution. Graphically, although there is nothing here that really tells you this, but graphically what's happened is you've got parallel lines. We didn't investigate it, but that's what you have. Because where do these two intersect? Nowhere. So when you get a false statement, you've got no solution. Is that okay? Which I think would make you probably guess what's going to happen on problem number 6. We've had no solution. We've had one solution. How about infinite solutions? We haven't had that yet. Let's see if that's what comes up. Problem number 6. I have 1/2 x minus y is 7, and I have x minus 2y is 14. No freaking because you see a fraction. Okay, is it ready for substitution?
No.
No, because I don't have an x equals or a y equals. Of all of 4 of these variable terms, which one looks like the easiest to solve for?
X minus 2y.
I agree that this x looks like the easy one, because I'm going to have one step to solve it, and now I'm about to do it. I'm going to take that equation off to the side. I have x minus 2y is 14. What do I have to do to solve for x? If I want x by itself, I'm going to add 2y, add 2y. That gives me x is equal to 2y plus 14. New system. I still have 1/2 x minus y is equal to 7, but I now have x equals 2y plus 14. I'm going to take this value for x, and I'm going to substitute it into the first equation in the place of x. And I'm not going to care right now that I've got a fraction, because it's going to work out just fine. I have 1/2 times, open parentheses, 2y plus 14, close those parentheses, minus y is equal to 7. I had looked ahead and I knew that I wasn't going to bother, it's not going to bother me to have that 1/2, because what's 1/2 of 2? 1. So that's 1y. What's 1/2 of 14? 7. So that's just y plus 7. Minus y is equal to 7. When I combine my y's, they cancel out, and I get 7 equals 7. What do you know about the statement 7 equals 7? It's true. And if it's true, that means that these lines intersect anytime 7's equal to 7. Well, 7's always equal to 7. So this is infinite solutions. Graphically, although you don't see it, but graphically what's going on is that these two lines are really the same line. They intersect at all of their points. So if the variables drop out, if you get a true statement, you've got infinite solutions. If you get a false statement, you've got no solution. Yes, sir?
Instead, even on that last problem, instead of multiplying that fraction in the parentheses, you just divided it.
Well, I multiplied by 1/2, which is equivalent to dividing it by 2. I really did multiply it, but when you multiply 1/2 times 2y, what happens? You end up dividing those out. So you had a feeling of division, but I was doing the operation of multiplication. Okay, do y'all have any other questions on this?
Okay, so wait, roll that down a little bit.
Uh-huh.
So